In this video, we are going to start talking about piecewise functions. This will be the first time we've ever talked about piecewise functions before, so we need to define what that is first. A piecewise function is a function, I hope that part's obvious, but it's a function that is represented by a combination of equations with each of those corresponding to part of the domain. Oops. This is a complicated thought just to read for the first part, so I'm actually going to come back into piecewise and just highlight the word piece for a second. We are basically going to take pieces of different equations and glue them together to make a new function, a new graph. The corresponding to different parts of the domain I'll show you in just a little bit, but we have to remember that domain is all of the x values that you're allowed to put into an equation. For example, if I had the square root of x, I can't put in a negative value for x. I would get non-real answers at that point. So I need values of x that I can plug in. And then the range is all possible output values, so what you get from your equation. So we're going to do three graphs side by side, talk about domain and range in each of them. The first two are very, very simple because they are just slope-intercept form. Okay, f of x equals 2x. Well, that means I have an intercept of 0, a slope of 2, so up 2, right 1. Or if you want, you can go down 2, left 1. Right there isn't, missed my dots. That right there is kind of an algebra 1 level line. Our domain is all real numbers. Any number you want to plug in for x, you can plug in. You get a negative number. If you plug in a negative, you'll get a positive. If you plug in a positive. Our range is also all real numbers. Right? You plug in a negative number, you can get a negative number. You plug in a positive number, you can get a positive number for the y. Not really all that exciting. For the second one, f of x equals negative x, it's still a very simple line through the origin. This time I'm going to go down 1, right 1. Or I could have gone up 1, left 1. You can put as many dots as you need to, but with a slope like -1, I hope it's pretty simple to just go through the corners. This one also has a domain of all real numbers and a range of all real numbers. In general, when you see a line that's in any sort of slant, you're going to have all real numbers for your domain and range, unless you're told you have restrictions otherwise. These are our two functions we're going to make a piecewise function out of. So this one right here is our piecewise function. This little bracket is going to tell us that if we have x greater than 1, we are going to use the equation 2x. But if we have x less than or equal to 1, we are going to use negative x. So I'm going to start with the if x is greater than 1. Basically, I'm taking this first piecewise function, or this first part from this first function. When I plug in 1, I'm going to have an open circle there. Okay, this is the same dot that I had right here, but this does not include x equals 1. So I put an open circle, just like when you first learn how to do inequalities. Now from that, I'm going to have my same slope of up 2, right 1. But I'm going to draw a ray through there. I'm not going to draw a line in both directions. For some reason, I can't draw and hit my own dots right now. We'll call that good enough. I'm not going to go down and to the left because that's this other piece, when x is less than or equal to 1. So when x was 1 over here, we had a closed dot. Okay, and now my slope, my slope is -1. I can't go down and to the right because all of those x values are on the red part of this function. So I'm going to go up and to the left. Now, these functions are just, or this piecewise function is just those two highlighted parts cut and put on the same graph. My domain didn't change here. My domain is all real numbers. Okay, the domain didn't change because no matter what x number I plug in, I'm going to get some output value. My range, however, has changed. My lowest value of my y's is -1. Okay? So I'm going to write this in these little braces. I'm going to write y exists or is an element of the real numbers. So I'm going to do that a little bit slower because the symbol is kind of weird. So y is an element. It's kind of like a weird curved E. In the real numbers is a capital R with a second vertical bar. But I'm going to put a colon here such that y is greater than or equal to -1. Okay? Because my y value of this dot is the lowest it could possibly be. Any other y value is going to be above that. So y has to be greater than or equal to -1. I'm going to put a little star next to this one because there are a couple of different ways we can write domains and ranges. So if I change how, or we talk about it in class and I show something different, it means the same thing. It's just a notation piece. All right. Have a great day, everybody.